while they're driving and buses and stuff for another 2 hours. So like 20 hours. Yeah. But honestly, it's not that bad. It's very nice.
Hi, good morning. I guess many people fly to US to take a vote for the next leader of the free world. I guess it's important because I guess that will be the dividing line for what we know, the current world we know, and the future. Depend on who will be elected. That will be very different, and that actually fit what we are doing today. Is a two-group sample and look at the difference in the two worlds. That actually fit. So let's get started. I guess it had been a week that we've talked, so I just very quickly go over what we've been doing because today we're going to finish this set of slides and then do very similar. Okay, because the idea is same, just like you're going to reject if something happened, right? You're just going to test. But instead of one sample, we do two samples, right? Just to remind you what we're doing is just very something very simple. But I guess this is something that you would do in a various different way, right? Because the main idea is different from estimation, where you try to extrapolate or extend your information from the sample to the population, right? We just reverse process is we have some idea what happened in population. We try to validate, try to see if the data support the claims. And we learned that the thing that we claim is we focus on the population mean as far as the one sample go, right? And then we look at the idea whether it's one-sided test or two-sided. They would tell you the left tail, right tail, and both tail, right? And the main thing is like depending on how you would, whether you know the sigma, then you will build the z-test, right? And the alternative hypothesis tell us where the rejection region lies, right? And that will actually fit all the model. If you don't know the sigma square, then you replace by the t-test. But there's some additional assumption because you don't know the sigma square, then you have to make the assumption that the underlying population is normal. That is the price to pay because of the fact that we have no idea what's going on for the sigma square. Okay, so that's important. But the good thing is when you focus on the idea of the proportional data, binary data is 0 and 1, the proportion imply that the hypothesis actually provides the variance because the population proportion also gives us the variance because there's a special case for the Bernoulli distribution, right? The mean and variance are the same thing. I mean, same means that they're related, right? Once you know the mean, you know the variance. So that means that, and also this kind of a binomial distribution, but it can be approximated by a bell curve. So everything becomes very nice when you have a proportion data. So today we are very ambitious. We'll finish the whole set of slides. Okay, and that shouldn't be a big problem because that's all the formulas, and hopefully have time we cover Excel how to handle those relatively easily. So don't worry about the formulas, although they're complicated. But maybe you only worry about it for exam, but otherwise everything is very straightforward. You can put in Excel and everything done in a very relatively straightforward manner. Okay, so the to save time, we focus on the idea that we assume the two samples and both samples follow the bell curve. Okay, so to save time, so the idea is the following, right? So we'll have observation from population 1, population 2. They're all simple random samples, so they all follow normal. Okay, and the sample mean and sample variance are denoted in this way, right? And we don't know sigma, but we know that on this unbiased estimate, so this is what we have, and all they follow normal, and the sample mean also follow normal. And we have the following, right? Because there's the mean of the sample 1 right, will follow a bell curve. The 2 will follow a bell curve. The difference will be a bell curve. So this is an important slide to drive all the result behind. Okay, and the use case would be, say I want to compare 2 stocks, A and B, and see if A better than B, or say the stocks, right? If the mean return of the stock A is better than B, right? And say the manager or scientist, right? Is it vaccine A is better than vaccine B? There's something we care, right? And we don't want to do the proof, okay? And we'll study 2 special cases, okay? And the first case we want to do is we assume that which we'll prove later at the end, use F test. So if we assume they're very the same, okay, and our test can be more accurate. So that is the special case that we will do is if we can assume the same variance, or which may or may not, we can test that part. It's not something that is too terrible, but just assume the special case. That means the same variance, then we can estimate the overall variance through this formula, okay? This is more efficient, and you can see this is a weighted average, right? So forget about the 1, right? It depends on N1's sample variance and N2 sample variance, right? And the fact that if you N1 have more observation, this will increase the relative. We just said you can imagine this is just the weighted average between the 2 sample variance, right? If you have more sample size larger for 1, then you weigh that more, okay? I'm not going to explain, but this is unbiased, okay? And actually it's more efficient, okay? Right, indeed you can show that any combination with the average will work as unbiased estimator. And this turned out to be the one that's most efficient one, okay? So that's why we use this one. If you don't want, this is the formula. You can just remember it, okay? And once we do that, because we assume same variance, that's a formula we have, right? The mean is 0 because that is the null hypothesis, right? Given this, this is 0, and we assume this, right? That's a simple t-test, right? Because that is a t-test idea, right? We replace sigma by SP, and this is the result, right? We have that already. I mean, there's no different from 1 sample, right? We say 1 sample, right? Because remember, if you learn from 1 sample, that's what we said, right? If X bar, right, under null, this is the idea, right? Right, this is the idea, all right? And then T equal to X bar minus 0, right, over square root of sigma square over n, but now we don't have sigma square, you S, right? So this will be T n minus 1, right? So the only difference is this n plus minus 2, okay? The reason why n minus 2, because you estimate the sample mean of both sample, so you lose 2 degrees of freedom. So the idea is like, we don't talk about that, but this is a little bit more tricky. Why minus 2 is because actually can be proven. The easiest to understand is because you estimate both sample mean, okay? So that's why the variation reduced, because once you fix sample mean, that what left over is just minus 1 degree of freedom, okay? But you just take it for granted for our case, then just apply, that would be the thing, okay? So let me illustrate, and you can easily see that the confidence interval estimator is the same idea, right? Just you want to estimate the difference by interval estimator, that would be the same formula there. But let me go to example, then you can see how it be applied, because it's very straightforward application. Just plug in the thing and then you can calculate, okay? So you have 2 populations, maybe boy and girl, or as I said, stock A, stock B, right? They follow the same bell curve and with the same variance, okay? And this is something that we will try to prove at the end, okay? So you may ask how we get that. Usually you don't have this assumption. But once you do F test, later we'll show you. If you can't reject that one, then you can apply this thing. Okay, this can be verifiable. Okay, and we have the sample one, N1 is 50, right? This is N1, right? And we have sample mean, sample variance, same N2 is like this, right? Okay, so we have all the things, we want to test they're same or not, okay? So because the same variance, then we can apply the formula down below, right? Which try to calculate the average of the variance because the same variance. So you can use the two sample variance to the weighted average, give you the variance, right? Because look at sample 1, the variance is 16. The sample 2, the variance is 9, right? And the best guess, right? You can use 16, actually it's fine. 9 is also fine. They're all unbiased, right? And actually anything between 16 to 9 actually all unbiased as well, okay? But we want to come up with the one that's nicest one, okay? That turned out to be this guy, okay? That is the best possible one, okay? Which the proof, actually, I put it in the slide. If you want to take a look, I think we did prove that that is actually the variance we want to calculate. But I really don't want to bother with that. So this is the idea. Okay. And the t-test, it just apply that, right? It just remind you of the formula, right? This is x bar 1, right? This is x bar 2, right? This is SP square, right? 1 over N1 and 1 over N2, all right? And that gives you negative 2.6, that's t-test, right? And we say the t value, right? If you go back to here, just to remind you what we are doing in case you forget, is the following, right? So we say x bar 1 is a bell curve, right? That is mu1, right? And x bar 2, use other color maybe, right? X bar 2, also a bell, right? And we say this also mu2. And the overall assumption is this is sigma over N1, right? This is also sigma, same variance, right? And we know that if you want to, the two bell, and then if you try to do a thing that is difference, right? It's still a bell, right? And this is mu1 minus mu2, right? And the variance we just add up, right? So add up means that sigma square over N1 plus sigma square over N2, right? Because they're random. But that means that the sigma square over N1 plus over N2 here, right? And we remember the hypothesis we have is mu1 equal to mu2, right? So this is actually 0, right? Then if we know the sigma, then you can use just normal test, right? Because basically just look at this normal, the bell, I look at, you give me the alpha, I put alpha over 2 on the both sides, then we know the reduction region, right? If this far away, then reject, right? Because the main idea is, right, if you look at the data, right, actually tell us, okay, if it belongs to this region, right? And this region will be alpha over 2. I'm talking about two-sided test here, right? Then I'm done, right? This is something we said, right? But the problem is this guy, the sigma is not known, right? We just convert to t-test, right? And the t will be just this minus the mean over square of this guy, right? And replaced by s, right? So the t, right, is just like this, right? And this t value will be just x1 bar minus x2 bar, right? Minus the 0, which is nothing, right? Because it's a one thing there, right? And over the square root of this guy and replaced by s, right? S squared 1 over n1, 1 over n2, right? And this will be T88. T88 is 40 plus 50 minus 2. So 90 minus 2 is 88, right? And then you would say, I would like to reject if this is too far away. So basically it's here or here. Over 2, over 2, right? If you want critical value, what's this value here? If alpha is 5%, so this is 2.5%, right? So this value, the critical value will be T inward, right? Because you want this area go back to here, 0.025, 88, right? This gives the value, and that one will be, as long as you calculate this guy, if fall within this region, then will be okay, right? Then you will reject, right? And this value will be T inward 0.975, 88. But do note that because the symmetry of over 0, so that's, you just need one, right? Because the other will be the negative side. All right, so go back to here. All right, so we have this formula 2.6 and you can 1.9, right? So basically, right, this is turn out to be negative 1.98, right? And this is 1.98, right? Can check by Excel. And the data, what we have tell us is also negative. Negative, right? So it's somewhere like here, right? Negative 2.685, which is too far away from 0. Then you reject x1, so x0 in favor of x1, right? So reject the null hypothesis of 5% significance level, right? So that is what we got there. All right, so that's why we have this one, right? So that's why we reject, right? And the p-value will be 2 times of that because the two-sided test, right? So you just calculate area 2.6 on the left-hand side to t this negative 2.625, comma 88, true, right? And then multiply by 2, right? That will give you the p-value, right? And the common interval, you can look at this is something exactly nothing very new here, right? Because here is here, right? And this value is just here, right? And this is here, right? So they're the same thing. Just put in and then tell us what the difference lie, right? Will be this one. Okay. So you can look at this, maybe the gender gap. Often this is the often study case, or the two stocks, are they different or not? You can estimate the difference between the return level. Okay. Is that okay? So now, if that's okay, and I want to introduce the same thing, okay? But only the denominator is different, okay? So the same thing, but different. You may ask how different it is, right? And we know that we can't simplify, right? So I cannot have single sigma. So I remain sigma 1 and sigma 2. So sigma 1, I use S1, right? And sigma 2, I use S2, right? So there's nothing new here, right? So probably you ask, why don't we use this always? The question is, to prove this is very difficult. Okay. The important part is the degree of freedom is come from a super complicated formula. That's the most complicated thing you ever seen in this class. Okay, even more complicated than the kurtosis or skewness formula. Right? You can look at. I mean, don't worry. This is the one that you can use Excel formula. right? If you ever actually do the calculation, right, for your homework, right? This is the formula for V. Okay. Amazingly crazy, right? And you ask how we prove it. We're not going to prove anything for this one. Even for graduate textbook, they don't give the proof for that. Okay? Because this is, I think this proof only have 60 years old. So it's relatively recent one, right? Because it's 60 years old. It's not something like other thing that you have been there for 100 years ago, right? So you can see there's nothing new, right? But just checking different, tell me the difficult part is which table to check, right? The T table has many tables, right? Depends on the degree of freedom, right? This is slightly more complicated, but otherwise, very straightforward, okay? Let me illustrate by example so that you know what's going on, because that is something that very similar to everything, right? Look at the example, I hope that will allow you to see what's going on there, right? The same thing, right? You have two samples. The only thing is we have unequal variance, right? They're not the same, right? There's no assumption that they're equal. So when we say not equal, then it's unequal, right? The probability of equal is very minor, right? And we have N1, N2, S1, S2. So that's what we want to know, right? So we have two population, right? So that's the question. The question is is this beta can sufficiently tell us whether they're different or the same, okay? So the idea is we do a two t-test, right? And because we don't know the sigma, right? So the formula is like this guy, right? The formula is, because remember, this minus this, right? Under the null, they're the same mean, so that's why the difference, where mean 0, right? And sigma square of 1 over n1, right? This is something we learned from chapter 4, right? So this is nothing new there, right? Because you say the same mean, right? So the difference must be located at 0, and the variance will be adding up, right? Because more spread out, right? Now, if I know sigma squared, then I say it's a normal test we find, right? Because the bell curve, right? You want to see whether data support this, right? This is the bell curve, right? X bar, right? Because under the null assumption, this is 0, right? And then we'll want to reject this one, right? If we have alpha over here, alpha over to here, right? If too extreme, then we say data doesn't support it's null, right? So we know sigma, then we're done, right? The problem is we don't know sigma, so we have to convert it to t. But normal, we know how to do it, right? The t-test, right? Just replace everything, sigma with s, right? And we can calculate this guy, right? Square root of this, right? Is 2.709. Okay. And okay, but now the question would be which table to check, right? Because it's again, we know there's t here, right? This is 0, there's no problem, all right? And alpha over 2 here, right? And we learn that is 2.7 is either here or here, right? So which the case, okay? Okay, and the critical value, the value down here, depend on what the degree of freedom V is, right? And V is determined by a complicated formula that we ever show you in this class, okay? And don't worry, Excel we done very quickly, but suppose it's the case, right? And the V turned out to be something super complicated. It's somewhat like 87, right? If you remember the last example, actually it's 88, right? So actually in this case, one less, okay? And if you know the t distribution, right? If the degree of freedom is less, that means that they're actually more spread out, okay? Okay. So that means that it's more difficult to reject, right? Actually lacking more precise. Okay. And use the t table, right? Again, you can do the same procedure, right? And you figure out this 1.98, right? So just the same, go back to this idea, right? Now it's T87 here, right? 0 is here, okay? You calculate it again, it's 2.6 something, right? If I remember correctly, right? 2.6, 2.7. Right, 2.7. Okay, and then you do the critical value will be this is negative 1.9, right? So you put 5% here, 0.025, right? And here will be 0.025, right? And that means that this is deep inside the region, so you reject, right? Or you can do the p-value, look at 2.7, left-hand side times 2, right? The two-sided one, and look at this is too small, right? Then you really can't reject. You really will reject, right? So the data can't support that the same, right? And the interval will be the same thing, right? This number here, this number there, and this number in the denominator, right? Numerator, denominator, critical value, right? That is. We've been seeing this all the time. Okay. Is that okay? Is that okay? So this is slightly a little bit more complicated, but I guess it's not too crazy, right? Because this is applying what we learned, right? If I know this for a normal, I can use the t-test, right? And because I don't know sigma squared, just same thing. The bell curve, I can know left and right, and then it's too extreme, then reject, right? So that's the overall idea because we apply the same thing, right? We keep the same thing, right? Is we have something bell curve, and again under the assumption, right? And then with the assumption supported by data, it should be within around the mean, which is 0, right? And if too extreme, then you reject, right? The same thing goes on here. Okay. Now, I hope this is clear. Don't worry, because you have time to work out your assignment, which we will ask you to do every single thing again. Then you apply once, then you know. Okay. Just please do your assignment. Otherwise, once we finish this today or tomorrow, we'll release assignment. Then you can work it out. Okay. Because hypothesis testing, you just really have to work it out. I mean, there's no substitution of not working it out. Unfortunately, this math class, so for this part, right, the procedure-wise is a little bit difficult. Now, here is one thing we want to mention. I think this is most useful one among the two sample tests is we look at before and after treatment, medical exam, right, medical test. This is something that we care, right? Usually, for two sample, okay, in what we have before the sample independent, right? Not the same individual, man and woman, right? That's unrelated, right? And here is the other opposite case is the two sample are having a 1-to-1 relation. Okay, actually the same guy. Okay, you observe them before and after very often, right? And why we want to observe them before and after different time, because you give them some treatment, right? That's why medical test, right? The medicine, you give him medicine whether recover or not, right? Or with some policy intervention, right? There's before and after. And in US, this is very common because when we do policy, in US, there's a lot of people try to do intervention, right? Say, for example, education, we want to say whether they want to have a small class, right? Or if you look at the marketing intervention, right? You just say, let's try to implement some new marketing campaign, right? New way of selling, and then see how we change, or within the company, right? You implement new policy and see how things work out, right? So this is the idea, right? So we have two samples that are mapped by one, okay? So that means that equal number of sample on both sides to the same guy. There's no missing, right? The missing we just drop, okay? So with individual I there, right? 1 and 2 represent before and after, okay? So the question is whether the difference between and after, right? And we make the assumption that the only thing we care is about treatment effect, right? We care about that. And we make the assumption that they follow normal distribution, right? And well, if they follow normal, I don't know the variance, but that's it's one sample test. That's a t-test, right? That's it. That's the idea. Okay. Let me draw a thing that actually is something simple. Okay. The assumption we make is this. So I have a bunch of x1, right? Someone before the test. Okay. I don't know what it looks like. I don't care. Okay. There's something I don't care actually. I don't even need to make the normal assumption. Okay. And here x2, which is after, can also be anything. Okay. But what we want to say, x1 minus x2 is a normal. Well, that's what I assume. Okay. Which we call D. Okay. And the hypothesis is where D equal to 0 or D not equal to 0. Del is here in the middle, right? So if it is the D, right? The average of the D is too big or too small, reject, right? So this is the idea, right? It's nothing very deep here, right? Just like look at this part and look at this part, right? Alpha over 2 here, alpha over 2 here, right? You calculate the data, right? Then you end up with that one. Okay. So let us actually see how this work out, right? Because this is rather trivial, so I don't want to. This one sample, so I don't want to spend too much time on that one. Right. So this is the idea. So the medical tests are two groups, treatment and then treat group. Okay. And you assume the same individual, right? Which is before and after, right? And same 16 guy, right? And I look at how well they're doing before and after, and I figure out that look at the difference of the performance of everyone. Average difference is 1, okay? And you calculate the sample of this sample mean of this difference, which is 2, right? Then assume the bell curve on D, then just a standard one-tailed test, right? So just standard one-tail, I'm not going to talk about that because this is exactly one-tail, all right? So basically what we do is we collapse the two sample tests into one sample, right? And one sample we know how to do, right? That's it. Is that okay? So I can see this a lot, okay? Let me very quickly go into the Excel first to try to do a little bit before we continue so that you have some idea what to do if you have data and how do we work on, okay? And, okay. One thing that actually can implement easily is the two sample t-test we just covered at the beginning of our class. And this is the t-dot test. You input x1, x2, okay? And then you ask them to do the right tail, okay? Right tail means the right tail test, just 1, okay? And you tell them this is 2, which is the equal. If your two tail is 2, I think the left tail is 3, okay? So that would give me the p-value, and then you like decide reject or not, okay? So let me go to the Excel. So usually this is the input for the data like this. right? But often you don't really need that, right? Because sometimes this is something that what we do is insert this one, x1, x2, right? The data is 3, 4, 2, 5, 6, 7, okay? And 3, 2, 6, and 4, okay? Now, let's us make it bigger, okay? So this is data, okay? Now we will do a t-test of equivariance, okay? And this all gives a p-value, okay? I want a p-value in case I want this left-right tail test. Okay, how do you do that? Okay, the answer is t-test, right? And then just put in the first column, the second column. You tell them it's one tail or two tail, one or two, and only one tail means it's the right tail. And then tell them which is whether you're paired, which is the case we just studied, or equivariance or unequivariance. So equivariance like this. Okay. So this gives you this one, and this one is one tail, but let's do the but the thing we want is in this class we didn't do right tail, right? You can do it because it's the same idea, right? You just put all the property there, but I didn't do it in the example, right? But you can do the two tail, and two tail with just the same formula. Okay, with x1, x2, two tail is just two tail. Okay, and this would, right? This is the answer, right? This is two tail test. Okay, and if you want the left tail, it's just one minus the right. Left tail is one minus the right tail, right? So this actually gives you the answer. Okay, but okay, is that clear? But to illustrate this is correct, right? You can calculate the sample mean, sample variance, all the calculation. You can verify this correct, right? I'm not going to do that, but you can see I do it here to illustrate this is exactly the formula that we illustrate in the class. Okay, you can. We have the green one, but the blue one is to apply the formula we learned in the class to show you exactly what we have is there. You can check it out. I'm not going to do it, but you can easily see how the formula being here. Right? So that's why we have to learn the formula, because you don't know actually Excel what gives you. Right? You have to see everything is there. Okay. So that's why it means that if the data you want to test, apply t-test very quickly. You're done. Right? Is that okay? So if you are not willing to assume the equivariance, right? You can do the t-test of unequivariance. Okay, we will try to show you when to use what at the end of today's class. Okay, if I want to do that, right, then I just the same thing, but I change the very last entry for this function. Okay, change to 3. Okay, p-value of the right tail, okay, will be just t dot test. Put in this A1 to A7 and this one, right? And then I want a one tail. And then I want to tell them I'm using the 3 option, which I don't make an assumption of variance, this most general one, okay? And for practicality, you try to do 3, okay? If you don't have good idea, okay? Because you don't know why we're the same or not, right? Okay. Then give you this number, actually very similar anyway, in general, okay? It shouldn't be too much different anyway. So if I do that, I do a t-test, okay? And array 1, array 2, data 1, data 2, right? I don't want 2 tail, now I want 3, okay? So this gives me the same idea, the p-value, right? It's too big, so I can't say they're different or not, okay? So again, this is to tell us what is behind, right? So this is the part that shouldn't worry us, right? Now this is the unpaired population there. Okay. And let me save the file first. Otherwise, now let's look at the case where we have the paired one, which I just being too lazy to copy. So for pair means before and after, we will have the same number of observation. Okay, say suppose. Okay, and it's a paired. Okay, and what we need is the following, right? We'll just do it again. Okay, this data, I do a run tail, I do pair. And the same thing goes on. Okay, I change it to 7. I change to 1. So that means that I can't rule out that the difference is different from 0. So very quickly, right? Just 1, you're done, right? So there's nothing. The important part is now computer is so convenient, right? It's just easy to click and then just come out the result. But you have to know what you're doing. It's very important because since it's so easy, that means that every one of you can do it, right? And why is you do it to make money, right? It's because you know what's going on, all right? If otherwise, why you're hired to do that, right?
Yeah.
Is that okay? How we do this two sample test here? Okay, that is how quickly it can be done. Okay, and so we've done that here already. 2 sample pair, the same thing. Okay, so what I will do after the break, okay, we'll be talking about something also very simple, which is something not surprising at all. We'll talk about this after the break, is compare proportion, right? If you have 2 special case of comparing 2 mean, okay? If you have 2 groups of data, right? One proportion, say suppose I want to care about, say, whether the proportion of boys like spicy food is same as the girls, same or not, right? Or you are the you are the CEO of the local media company, right? You want to know one top team here is Mirror, right? You want to compare whether proportion of the men and women like the team are the same or not, right? Why don't I do that? Because you want to try to sell, right? Suppose you are doing the skincare company, right? Then whether you want to depend on the composition, right? What kind of advertising campaign you want to target through the fans of Mirror, right? Suppose you have a contract with them, right? Whether you want to sell more woman product or man product, right? Depends really on the proportion. Okay. So as you can see, Is it a bell? Is it a bell? The difference of a bell, right? And the good thing is, we can replace everything by the sample version. It's still a bell, right? So everything I use is set test, right? So that means that this guy is a test, okay? And that is how we do here, okay? There's some complications on how to estimate thing in this formula. Denominator is slightly different, okay? But we'll do it after the break, okay? Don't worry. We only have this last one, an F test, then we are basically done with all the hypothesis testing, okay? And it's very mechanical, so I run a little bit fast, okay? But if you want me to go a little bit more detail, we can go a little more. Let me know in the U reply, so that I know whether I need to go fast or go slow or the speed is okay, okay? But I go around to see if you have any question. In the meantime, please fill in the U reply so that I know whether I'm going too fast or too slow, or there's some particular question that you want me to go in more deeply, okay? Because they're already applying the same formula, right? So there's nothing way too much to explain and discuss, right? Because basically the bell curve and just apply the same thing. Okay? Logic the same. Let's a break. We'll resume at 10:32.
因為 T table 有時間就8年，我會覺得如果係咁嘅話，我考試咪要入呢個即係總之就係你係 platform 俾我哋，甚至做嗰個就夠咯，我覺得就考試跟住即係你話呢個。係我呢條識我呢個係文學嘅呢條，你呢個已經熟得佢。我問你要估計下佢哋嘅 difference 係，講話即係佢問嘅時候，但係呢個前呢個 up 呢個即係呢度就係跟呢度就 confidence。幾多課？呢個就係話我哋為嗰個下次佢都拗。今朝放兩場，嗰個為監考台監考即係話我哋個 P 就話其實有陣就幾大個可能性，譬如佢某研咁講咗，出現呢個嘅機會。首先 assume 你用步驟，然後我覺得你結果係即係有幾多機會差唔多，即係話有機會係你個嬲喺度啦。咁呢個 value 又話呢個啱嘅，有幾多機會出現？即係有幾大可能性呢個機會係啱。個 P 好細嘅，就話出現到呢個數據嘅機會個可能性太細啦。我覺得係呢個 H。而且我哋嘅 approach 係 assume 嘅出嚟係即係我哋所有合作社佢假定咗佢有呢個假定係啱，我哋雖然假定就話聽過我哋假設啱嗰陣時。個 data 個數據係咪支持過你嗰個 個推論，即係我哋推論解零嘅推論啱嘅，我哋推論。
其實你唔講我係知嘅。
係啊，就啱講佢。係好接近，但係因為如果 two tail test 嘅話一樣，但係個 one tail 就唔一樣。個 two tail 嘅話就係一樣嘢，因為個 confidence 裏邊就係 acceptance region， 外邊就最即係可以講一嚿嘢。喺我哋呢課，但係 in general 唔係講嚿嘢，因為佢 two tail 就唔係 one tail 就唔啱。
3年個字。
考試
不情。
而家好多科就考試咁，我覺得而家都應該係寫出嚟㗎啦。
其實 central 少。
啊？
其實3個我覺得 OK 嘅。
centralize 覺得好快。
我想講我有個 friend centralize
我哋應該考試嘅地方係小學嗰個大嘅時候，
即係
要排
呢個 TMS 基本樣。
哦。
佢台好長台，有時話俾你聽，叫你出埋咗大陸。將又開出嚟。100個100嘢長死。係咯，呢個舊嘢應該可以，咁樣大家睇睇咗。跟住你要拎晒所有嘅架撐出嚟。
要攤晒周圍，呢度都唔夠位攤。
我講翻話俾你聽，但係大概定好啦，要確作實先講。
係啊，
要批嘅嘢，要推薦到，翻入嗰度。我過嚟。
你太艱辛啦。
我知道好難㗎，我容易啲嘢。
我想問咧係，即係我想嗰個其實聲我可能話
聲係我基本就係話即係話你翻嚟就係你中唔中意食辣椒啊？
即係零嚟嘅，
係咯。咁你計翻個邊嗰陣時，譬如話你10個人裏邊有4個。咁你反正就係唔係嗰個點？成個成幾
即係先會有4個係中意食飯。
你點樣咁食首先係
因為食你會1個人嘛，如果10個人就多少人？哦，6個零。
佢班先咁樣 expect，
咁樣 average 嘅話，由4加4，即係4個1。16個零，再除以10，咁咪就佢邊就係1同0嗰陣時，個 portion 就係個邊嚟食。
同埋嗰個 T distribution 我一直都唔明，
我因為
翻工
你個 band 做咩嚟？咁咪
所以6號算啦。
佢個 band 做咩嚟？嗰啲大概係咁樣。咁你講0，咁你喺0，你知道個 幾肥嘅，佢哋咪知道。
係咯，其實我哋你為
係啊，超過我手嘅啦，即係點講都好啦。大個細個，即係大個點整下啲個細隻個。但問題係唔知佢食埋唔食埋呢個個 sample 有個 sample 俾人嚟睇，個 sample 講咧，要滿之後要減翻個除翻嗰個。
但會唔會話有時係 sample 係深挑嘅有個感覺？
因為 sample 夠大嗰陣時咧，你 T 同個
即係 T 因為 sample 夠大係趨近我，係啦都但係如果太細咧就
夠用 T， 但係如果 T 夠大，即係話 N 夠大嘅 sample 夠大，一樣啫嘛。
所以，但我想問，因為頭先即係頭先係個例子係40同50，
我都細嘅啫，都細，起碼要300、400。
啊，因為大過30嘅 OK。
嗰個係大過30，你嘅 sample 佢係 follow normal，就算佢本身嗰個係要 sample 呢啲。嗰個我哋話大過30，嗰句句子係話，我唔理佢嗰個 underlying population 點樣分佈，點樣佢 sample mean 都係 follow 到比較強，嗰個係30。
跟住嗰個 sample mean
讀咗啲咩？
即係就會話如果夠大就個 sample mean 就趨近於呢種。
sample 唔係喎，嗰個係 log last number 唔需要擺。
咩嚟㗎？
第一件事 log last 叫 last number 嚟嘅，個 sample mean 會無限地咁接近個數理上面，主要 sample 大。第二個 central limit 嘅話，如果你唔理本身係咩，你開始個 underline 係一個好奇怪嘅數，但係如果你照揾 sample mean 嘅，佢都係佢。即係咁，但係你先大家唔係呢個 box，
即係純粹係30% sample mean 係 M
即係 N 就sample size 咁個 sample， 我以上咁呢個先係全部都相對嚟講。
不過有時間。因為細 N，
係呢個係冇啱冇嘅 ，N 係最好大嘅 sample distribution 嘅 sample mean 係咩？
係咁呢個細 N 唔係 sample size， 係 N 加數。咁
你知細 N 就冇大 N 嘅。
係咯，大 N population 細 N 個 mean，
你定咗個 sample size 之後，係繼續揾個 sample mean。sample mean 係一個 random variable，佢決定你係揾咗邊個 sample。佢有一個分佈就
即係個 sample mean 再幫佢。
係啦。
哦。
因為你 sample mean 係唔知揾到咩，每次都唔停咁就可以。咁但係佢話一張 mean 出嚟俾我聽，佢係呢個。
即係如果你攞呢個 sample mean，
你攞無限個 sample mean 出嚟，
就係一個 sample。哦。我以為係話一個 sample， 如果係 N。大個三冇，你揾咗一個 sample， 只係一個數字嘅，點會有你揾之前你都有噶嘛？所有呢啲咩分佈嚟嘅，你未做咗分佈，我做得咩分佈？哦 ，OK， 做咗一個數字啫嘛，冇分佈嘅。未做先覺得佢係個 bell。嗰個都係未做，我哋係未做之前有啲嘢。哦，即係做一個㗎啦，成班都有數字，覺得可能即係有多個係 sample mean plot 出嚟嘅 sample 啲。係啦，冇錯，係死啦，一直錯。俾你可以做好多都係，就上完啲堂都未做過嘅，你起碼叫明白好好嘅。好多年上完之後就識得 apply 個 formula。我盡量可以清楚你 apply formula 大概就發生咩事，即係唔需要好清楚知道嘅，但係大概有個 idea 發生緊咩事。如果唔係都，如果唔係啲課就唔可以冇 formula 照對啫嘛。係。唔好賴下生可以做嘅，真係照佢做。2到8係啦，H 有佢做住嘅，你話係咪一樣啊？拉一樣，做完咯。我冇教，我一堂教1個鐘教完所有事。所以 exam 唔俾我 exam。exam 係啊，因為
但係你可以諗成我哋唔識細球，其實條問到其實仲會有着數嘅啫，咁樣簡單啲噶嘛。
係啊，咁啊係。
係嘛？即係如果我唔識細球，基本上你係就係，我就係如果唔識細球，你話 X 嘅方面嚟咪得咯，係嘛？如果我咁問嘅話，咁就先梗容易啦。
計都唔使計，
更加計都唔使計，淨係抄嗰個方面啦，嗰度咪咁做完啦，係咪？最容易係咪？我唔係擔心，最容易嘅。
OK。
我想問下你都叫師傅啊？
唔係啊，師傅。
不驚啊！我而家對 C.B.A. P.A. 啊，呢個係嘅。
係咪都會
It's really stressing me out, but
跳啊跳啊真跳啊！唔係係即係大跳。
yes,
and then you would change days for that.
咁呢個應該
check 下咯，check 下知啦。
it just breaks my heart that it's so close. It reminds me of so long years.
Wow.
If I ask you, is this happening?
咁佢
即係 capitalist people and the people not working. Just way. I mean, there's always like economics. There's always there's a policy that they're working. Better for everyone. How to allocate the gains and also there's always we face overall. If you're working for us, you can buy it. Job post or your shareholder.
That is a very good perspective. So everybody got a different. Everybody gets something.
If I make I make a class model. Those people are hungry to learn. That is happy. Those people who are paid overall for them happy. Overall and end up is better for everyone. Some people of course never stay there.
I wanted to ask when all the polls close, does that mean that it's not the probability of one, it's the confidence?
Yeah.
Because it's
not.
It's either
Yeah,
yes.
it's not. It's already there's no more random. It's there. Confidence left. No more. Of course, if you're paid, okay. You can be Bayesian or because it's a classical probability that you can also calculate. But now we say for Bayesian, you still can have probability to represent your belief. That is called subjective probability. That is fine. That's fine. That's axiomatic. Don't allow us to assign probability unreasonable. That's why it's okay.
It's okay.
It's okay. Classical is not. Classical means long run. Something can happen. It can happen again. Now, if you believe the basic perspective, already just you assign some number to something. You know, by base. No problem. You can say problem. So the classical meaning of all these is difference in this idea. So we do your
So that's why.
That's why.
Yeah, that makes sense.
Once you draw it.
I asked that because I was, looking at something in the stock market, like once it occurs, but we don't know, and you're trying to figure out who gets what, like in settlement, that settlement, like, and once it happens, like once everything's set, so you just gotta figure it out. That's it.
Right. Once it does this, you become confident. Yes or no? This is a classical sense. But if you're Bayesian, it's okay. But the same thing, just the name, same thing.
I wish we could know that because if we could just skip like 10 hours right now.
Yeah, but this is always like this, right? You can always want to jump ahead, but
That's like.
that's how you grow, right? You learn how to be patient.
Right.
I think everyone wants to know. Not just you, everyone knows. What is two sample equal weight. Okay, it's just saying that the two groups have the same weight. That's the graph I said at the beginning. So that's the idea. So go back to the very beginning of the graph. Okay, equal variance means we assume the true sample, right? It's like you look at it, compare man and woman. Okay, look at how much they like spicy food. Okay, and you look at it's following bell curve, right? And is it going to be the same variance or different variance? Right? If the same variance, then apply the same variance formula. If they're different, then you apply the different formula. Did I have that here? I don't have that here, but you apply different formula. Is that okay? I guess this is what it means. Just simply how this spread out. Okay. If you don't assume this can be something like more spread out like this, can be anything. Okay? I hope I explained this. Okay, but if you still have questions, please feel free to ask. I want land or land grade. Land, okay. Land means good grade. I thought it meant the other one, land means bad grade. Okay. We're the same.
No.
Land means good grade. The probability of getting good grades is not that low, right? Because our median is like B+, right? So only if you're above the median, slightly a little bit more, right? Then you can get good grade, right? I mean, if you think B+ is good grade, then already it's not that difficult, right? Just around the average, then you get good. On page 2, sample variance 101, let's see. 101. Did I do 101 so far? Oh, this one? Oh, this is the p-value. So here I don't do the t-test. You can go directly to p-value because the p-value is the thing that makes a difference, right? So you can do, suppose this is the equal variance means I assume, right? Suppose I compare boys and girls group. I want to see whether the percentage of people live in Curry for boys and girls the same, right? I want to test that one. And this is the data I have, or not percentage, maybe this, how many boys, how many hours they spend on, say, the YouTube, right? And it's girls, right? Look at difference, right? This can't tell their difference, right? Depends on you are talking about the right tail test or two tail test. All right, I hope that explain. I don't know what to explain. This is the p-value. So the p-value is whether you reject or not, right? It's whether reject. This is asking this, although it didn't cover, but you should have no problem, right? It's saying that mu1 equal to mu2. This is well known, right? This is saying that mu1 is bigger than mu2. This is the p-value of the t-test, right? And for the two-tail, this simply means this is the same. Sorry for my writing because I have to use the mouse to write. I don't know that this doesn't work for some reason. Okay, so I guess if you write by mouse, you also may not be right better than I do, but but this is what it means, right? Right. So there's the p-value, right? That's very simple, right? If you want to reject this, you want this to be very small, right? Then you reject. It's the p-value, right? It's hypothesis for that one. So this goes directly to the very end of the story. Okay, I hope that it's okay. If you're still confused, it's okay. Just keep asking me, or with assignment, you can do it. Okay, then you know what's going. Whether you know or don't know. Yeah, hypothesizing. Overall, it's very simple, right? We just know the sample mean or some measurement from the bell curve. We see it's extreme or not, right? If extreme, then reject, right? Day for the final will be the last day of this course. I think it's
27.
maybe 27. Okay, 27. So assignment good, please do the assignment. oh, can we bring one cheat sheet? Oh, you can bring as many as you want. Okay. Again, any law-abiding article paper will be fine, right? No pornography, no anything legal then can be brought. Okay. But do remember you can't share your notes, right? Bring your own set, whatever you can bring. Okay. I don't mind. The normal table you can bring because that is the purpose of this 9. Okay, you can, for those who, you can bring whatever, right? So you can bring whatever table you want. And this set of tables should be sufficient for the purpose of the exam. Okay. Just to make sure that in the rare event you didn't bring your tables, we just use the Excel formula, we'll give you some credit for that. Okay, just try. I mean, we're not that bad, right? So if you somehow can't find it, put the Excel formula there, and then we'll give you some credit, partial credit for that. Not the full credit, right? But we'll give you something, okay, for doing the right thing, okay? So don't be too stressed out, but do remember to bring your table because the problem is everyone will have different taste or different table. I give you the one, you can bring whatever, okay? You bring the one you like the best, okay? The p-value, okay? The p-value is, okay, let me talk about the p-value again. So someone asked this one, so I hope I try to explain a little bit. So I use a two-tail idea to explain the p-value, okay? So remember, suppose I have the X bar, okay? And suppose the very simple case, I have the null hypothesis, mu equal to 0, and x1 mu not equal to 0. Okay, the simple case. And let's make the simple case. This is known. Okay, I can use the set test. So everything becomes the easiest case. Okay. Under first, how we do hypothesis testing? What we do is assume this is correct. Okay, and do remember our assumption is this is bell curve. Okay, and under this assumption, this is 0 here. All right. So we say whether data supporting the claim is 0. We want to see the data, is it far away from 0, right? Because you say 0, right? If exactly 0, then you're done. All right. And we will say this is far away from 0. We have to pre-specify what is the significance level, right? Which usually is 5%. All right. And for two-tailed test, it means that it's far away from 0, means that I have 2.5% on both ends that I'll consider beyond those values are extreme, right? So that means that I put alpha 2, which is 2.5, or here for this, right? And if our data fall within this orange region, then they're called rejection region, and then we'll reject X null in favor of X1, right? If it is outside this region is close to 0, then we don't reject. This is an idea, okay? So that would idea, right? We'll specify the alpha, and that will give us the region within that we don't reject outside, we reject the X null. So we are trying to decide with the X0. Now comes the p-value, right? The question is, okay? The p-value is we change the alpha such that it just get rejected, okay? So the idea is following. Okay, suppose our data is somewhere here, green one, the green one, okay? The p-value is just basically, loosely speaking, is the probability that this comes out, right? If low, then we reject, right? To compare, that's why we reject. The p-value is too small, we reject, right? Because it's very unlikely it comes out, right? So how do we do that is we change the alpha, right? Because we change one, we change the other, right? And with this area, right? So that's why we look at the area time multiplied by 2. That's the p-value. Okay, the p-value is, loosely speaking, is the probability that such outcome comes out. If this is so small, so unlikely, right? The probability is defined as you adjust the alpha such that it just get rejected, right? So just change the alpha, right? That's good, right? Do notice hypothetically we change the alpha, right? But we fix the alpha and decide the rejection. But suppose we just reverse the process, we look at the result first and adjust the alpha such that at the end, is it rejected or not, right? If the p is so small, then it's very unlikely that this data comes out based on the assumption we have, then reject. Is that clear? Is that clear what the p-value is? Okay. The two side is slightly difficult because, right, you multiply by 2. The reason is like this, right? Because you adjust the alpha such that it just get rejected. Okay. This is what we define, right? This is, look at the slide, that's how we define what the p-value is. I hope we made clear. But the simplest case is, well, you always have this come from the machine, right? So basically what you do is p-value is low, reject. Otherwise, you keep it. I hope that's clear. If not, then just tell me again, I try to explain. We have 5 assignment. I think we're 3 assignment already, right? Assignment 3 have been released, right?
No, not yet. No.
Okay, I'll ask you. Why she should have released? Okay. I told him to release it long time ago.
冇啊，係啊，都冇啊，放上去。
唔係都係得。
Oh, hidden from student. Why?
係都唔知得。
Why hidden from student? I don't know. It's B.A.
時間
即係
幾時間？12號。
12？哦，一個禮拜都得嘅。
12號啊。
I don't know why the TA hidden from you guys.
會有個。
遲少少得唔得？
Yeah, I can just adjust the deadline a little bit. Yeah, I don't know. I mean, I told him to release, but for some reason,
但係一直都冇。
yeah, we just add 1 more week, right? That's fine. But the problem is we are assignment 4 as well, because we're done with the hypothesis testing. Well, do remember, you got just by attempting, you get most of credit. So don't worry. I mean, I don't know why the TA is not release it. So the assignment 4 will be hypothesis testing. So we're done today. Okay. Thanks for letting me know, because I told him that like he should have released it like 2 weeks ago. Last week, because you get 2 weeks, right? So it should release 1 week ago. But I didn't know why he didn't. So not Friday yet. I hope some of you want to go to Friday, but not there yet.
又水入嚟啦，又水。
Yes, that's great. 1 tail, 2 tail. Yeah. Oh. So you're sleeping in a library? I hope you are not. 1 p.m. mass dance. Okay. I don't know where, but there's a advertising here. Deadline. When's the deadline for our project? Let's see.
1st of December。全部都係㗎。
Where's course outline?
冇問題。
No. What is our project?
可以係嗰個 English。
I think we can allow a little bit more, but but we can't go that too far because I still have to submit grade. 1 more week, I guess. 1 more week. That I think that's the best I can do, right? 1 more week, because I still have to grade like by the mid of December, right? If you allow me to, sometime to grade. Remember, I have like 70 of you have to grade everyone.
Yeah.
Right. So just add 1 more week to that. Maybe I change it here, right? In case you. Oh, there's no submission, right? I put a submission that it will be like add 1 more week, right? Add 1 more week to that. That will update it. But do remember, you don't have a lot to write, right? I think everyone just have one A4 paper, so it's not something that too terrible, right? It's not something, at most 1 A4 paper. So don't overwork, right? It's not something like you have to work a lot, okay? Yeah, only 2 weeks to finish. I think at the end, probably you will learn a lot, hopefully, from this class. I know there's I apologize for our TA because I should have checked his assignment. I mean, I don't want to fully blame him because I take the responsibility to not check. I thought assignment 3 be there, but sorry about that. But we extend the deadline for that, okay? So that you don't. But the problem is all the assignment combined a little bit together. I'm sorry about that, compressed a little bit, but you still have the 2 weeks to handle that. I'm sorry about that. Okay. So kind of like some delay on the research project, and also the deadline for assignment 2 is a little bit 1 week after that, the original deadline. Okay. So what left is just 2 different tests, so don't worry about that.
即係你其實交2份最多成。
So here comes the very last one. The last 2, right? The proportion, right? Just to remind you what it is, proportion is just data either 0 or 1, right? The mean is a proportion, right? We just add up. And the only troublesome part is the following, okay? We know that this follows the bell curve, another bell curve, the bell, right? So, but we want to test at the same. This becomes 0, okay? Right? The only problem is, what are these? Okay? And the idea is you have to get the same, then you have to come up with the best estimate for pi, right? Because say boys and girls have the same proportion of people like spicy food, say, right? But that means that if they're the same, right? Boys and girls same proportion, means that there's no difference between boy and girl. You can easily estimate by looking at how many boys and girls together like spicy food, and look at how many people we ask in total, right? That's the best estimate of the pi, right? It's just this add up how many people like and how many people in total. Right? That's a p bar, right? That is the estimate of, just forget about boys and girls, right? Because you say number of proportion of boys and girls like spicy the same. So when you actually estimate this p hat, right? People like, just simply forget about, just look at how many people like spicy food over how many people you ask. Forget about the grouping, right? Then this is the p bar. And once with that is simple. You know how to estimate this pi, that's a standard normal. Right? So that's the idea. Rather, intuitive, okay? I guess in general for this type of testing, in general, half of the class will don't understand what's going on, okay? From my experience, most of people can apply formula, no problem. I think 98%, 99%, at least after the assignment, they know how to apply this formula. But in general, half of the class will not know what's going on. They will know the formula, but they don't know why it's true. It's normal. Okay, if you don't know, it's okay, because when I'm a student, actually I don't know. But after taking many classes of this, I know what's going on. I mean, it's okay not to know, okay? I mean, but the minimum requirement is to know if you want to test, this is the formula, you apply it appropriately, then it's fine, okay? Knowing what's going on, why this formula work, somehow we have a little bit, require some more math, okay? The only thing that I want to highlight is this interval estimator, we cannot use P-bar here. And that is the only tricky part for this one. The reason we can't use P-bar, because when we do common interval, we can't assume they're the same. So we have to use their own proportion in their own. So which is larger, okay? You use the P-bar, this is smaller. And if you do make the assumption, the interval will be larger. Okay? But usually this is come up from the computer will give you this thing. Not Excel, but if you use a more advanced software like Python, this domain comes out. Okay. But in any case, this is something that have to be worried. But you do the assignment, so don't worry. Just apply the formula one by one, and you know what's going on. So this is data, okay? Final data, which means that whether they like spicy food for boys and girls, right? And suppose that the boys ask 50 boys and 60% like curry, and 40 girls and 70% like curry, right? And you want to ask, they are not the same, right? 0.6 and 0.7. The question is whether the proportion is the same, boys and girls, right? Of course, if the girls are 0.6, then you can go home, done, right? But they're different, so you have to do something to see whether they're same or not. The first to do is, okay, forget about boys and girls, okay? How many people like curry for boys? 30, right? 50 times 0.6, 30, right? How many girls like curry? 28, right? 30 plus 28, 58, right? So if you forget about the group, 58 over 90 is the number of people who like curry food. That's it, right? And that is the best guess, right? If you forget about the grouping, right? Now the question is, want to see this guy, right? Remember the proportion or the bell, okay? So just apply the formula, right? Because different the bell is still a bell, right? And this is the denominator, right? This is, remember, this is p hat. This is 1 minus p hat, right? And times 1 over n1 plus 1 n2, right? And then you do the same procedure, right? Look at the z, which is near to 1. And then you know the z is 1.96, so you can't reject. You know already, right? Because 5% 1.96, right? Two-sided test. So we're done. Right? Is that okay? So in case you're not following, so that's what we have. Just let me repeat a little bit because I hope that stick to your mind. Again, right? So we have the proportion data, 0 or 1, right? And although remember data is 0 or 1, but the sample mean the normal. That's a bell, right? The raw data is 0 or 1, but the average is a bell curve. So that is a very important thing, right? So it's a bell curve, right? Of course, the mean will be pi 1, right? The variance will be pi 1, 1 minus pi 1 over n1, right? This is something we know. A special case for the proportion data, right? That's what we learn when we have chapter 4, right? Sampling like this, right? Although remember data is 0 or 1, but the proportion, the mean, is actually the bell curve with this, right? And we can have the same idea here. P2, right, is also pi 2 by bell curve, right? So do note that, right? Now is we want to see this and this the same, right? And so that's why what we want is look at P1 minus P2, which we can collect data on, right? Look at sample proportion. And because 2 bell, right? This will be a difference, right? And the variance add up, right? Just pi 1, 1 minus pi 1 over n1, right? Pi 2, 1 minus pi 2 over n2, right? So we have the null hypothesis saying that, okay, they're the same. Pi 1 equal to pi 2, right? Not equal, right? So this is becomes 0, right? And this with the same thing here, right? And this is estimated by full P bar, right? The bell curve, you know, replaced by that, right? Then you know this is alpha over 2 here, right? Right? Then you can know how to do it, right? That's the idea, right? There's nothing, I mean, we have done this many, many times. It's not, right? It's nothing new here, right? It just, if this proportion is within this region, you don't reject. In this region, you reject, right? Then you can convert to standardize it, right? Look at the data minus 0 over the square root of this guy and see where actual data is, right? That's we know that, right? Right. So that's how we get this, right? -1, so it's far away from 1.96, right? 1.98, right? So we have to reject, right? The only part that probably that is tricky will be this guy is here, right? And this guy is denominator here, something, right? This guy is not this guy. Do you know that this is not the case? Not this guy. Okay. Of course, this guy is still this guy. Okay. Why not the case? Because hypo-testing, you have one assumption that they're the same. Then you can replace that by a simplified formula. But if not the case, they're not the same, then you have to estimate it pi 1 and pi 2 by P1, P2, not the P, but the P bar, right? Because this is supposed to be pi 1, 1 minus pi 1, pi 2, 1 is pi 2. If under the assumption, you can do the P bar to estimate both. But now you don't use P1, 1 minus P1, P2 minus P2, right? That's the main thing, okay? Again, if you don't know, that's fine. Just apply a formula. I don't think now you get to the CHK here. I don't think you have problem applying formula, right? But just to okay. Here comes the very last one that I hint at the beginning, right? Where I want to say I have two group data, the bell curve, okay? I don't know whether they have same mean, but I want to see whether they're the same variance or not. What I care about that, that's finance application. I have two assets, right? I don't know whether they have same mean return. I want to care about whether they're same variance, same risk, all right? If actually you can't reject the null hypothesis, you can do the t-test, right? See that the mean the same or not, right? That's how you have the assumption whether equal variance or not, right? So let's go back to this one to remind you what's going on here. So remember the overall idea, right? We have to compare woman and man, right? So this is a question, right? And then maybe looking at how much they make, right? Suppose, right? And our assumption, right? Usually we have bell here, right? May have some mu1, and this is sigma 1, right? How it's spread out. Maybe woman will have another one. Also a bell, mu2, sigma to square, right? How it's spread out, right? So the question is, before we ask whether these are the same, whether the gender gap, okay? If this the money, all right? Now we don't care about this part. Now I care about whether they spread out the same or not. So we're asking whether this is the same or not same. Okay, we don't care about the mean. Okay, is it the same variance or not? Right? And remember why we don't do that first? Finance by directly application. The second one is the t-test, right? The t-test we said we'll compare the two. If we test this, if we can't reject it, we can use the simple t-test, right? If not, then it will be more complicated one. Okay, so that is the idea behind. And interesting part is the test is very simple. Turn out to be, is probably is as simple as you would think. I want to compare the variance, the same or not. Why don't I just set the ratio of sample variance? Right? The simple is, right? And the question is how I compare this over this. Okay. And the question is the sample variance of sample one, right? Look at the boys and girls, look at the ratio, right? And if this ratio is too large or too small, then you can't say the same, right? Because if they're the same, it should be 1, right? If this is 2 less than, very close to 0 or close to infinity, right? Then, or too large, then you would reject, right? So the question is how this looks like, okay? Turn out to be, this question is very complicated, okay? But this one is follow F distribution, okay? And this, there's so many tables. The table looks like it depends on how many samples you have here. It depends on n1 minus 1, n2 minus 1. Okay, so it means that the table is not ordered by a number, right? T have only one number, right? It's you from set 1, 2, 3, 4, 5 to infinity. It's 2-dimensional table. You have to check first. Tell me how many samples you got for the first one, minus 1. How many samples you got second one, minus 1. This is a table. So it's 2. The table to check is very complicated, right? Before, just like it's a table number 1, 2, 3, 4, 5. You can put the table on a line, but now table is a plane. Tell me which row, which column, and check that particular table. Okay, for Excel it's very easy. Just put it in there, but that will be the idea. Okay, so this is called F test. Okay, because why F test is slightly complicated, right? Because this F should be around 1, right? So F depends on the shape, can be something like this, if you remember, something like this, or can something like this, can be weird shape, right? That means that you have to calculate the if alpha over 2 here, alpha over 2 there, will be 2 different values. So the F, the left and the right are slightly different. Okay, it's not symmetric, right? Because when we learn the T or Z is symmetric, you calculate one, the other one is negative. So the critical value here will be there are 2 different numbers, right? There will be the right-hand side and this left-hand side, right? But again, the same, if you're more extreme than the value, then you reject, right? So let me illustrate the idea. Okay, I promise you this last test because it's last slide already. Okay. And it really depends on the F test with the left tail and right tail. Okay, but let's see the example, then you'll be very simple. Okay, so I have sample size of 50 with sample variance of 30. The other one is 40 over 20. So you can look at the ratio, it's 1.5. Okay, so the question is like this. You look at this, under the null, it should be somewhere near 1, right? And the question would be, okay, now it's 1.5, okay? Is it far away from 1, right? Again, the question is, I have to look at this alpha over 2 here, look at alpha over 2 here, okay? And check if the actual orange is in the blue region or not, right? If the blue region, that's far away, reject or not. If not, don't reject, right? Same thing, there's nothing new there, right? We follow the procedure again, right? The same thing. The only troublesome is this not symmetric, okay? You need to check 2 numbers. How do we check? Okay, remember the data we have is 50 and 40, right? So just use the Excel function. What is this number here? This will be just F dot inward on 0.025, right? Because suppose alpha is 5%. And you just put 49, 39, and then we're done. Why 39, 49? Because you use 30 to over 20, right? So 30 come from the sample of 50, you minus 1, 49. The denominator is 20, come from the sample size of 40, minus 1. So you check the 39, 39 table, okay, of the F table, and that's it. That's the left-hand side. And the right-hand side, this value is just F dot inward on 975, okay, 49, 49. That's it. Right? So that is slightly a little bit more complicated. Okay. But it's the value, right? You can do the p-value the same, right? You calculate one side and multiply by 2, and that's it. Right? Look at the one that's closest and multiply by 2. Right? And probably one final question you might have is, if you swap this one, right? The result is the same, because to swap this one, this thing will swap a little bit, so everything become one inverse, the same idea. That's how I show the slide. So it doesn't really matter you put which is sample 1 with sample 2, the same thing. And at the very end, probably I want to show you the Excel. Turned out to be very simple, amazingly simple. Okay, let me show you the Excel formula. Is that okay? Excel here, I do a F test of variance. Okay. This is very simple. F dot test. Give me this guy and to this guy, and I'm done. I think F test gives you the right tail. I forgot. Sorry. The F test is here. This two tail. So the standard one. So this is two tail. So in this particular case, I can't reject they're the same variance. Okay. And now you can't reject it. That means that you apply the first 3 row idea, right? Because you can't reject they have different variance. You can apply the study there. Okay. So that's how you think whether it's equal variance or unequal variance. That's how F test being used. Okay. And of course, by itself, F test will be useful. And what we'll do in the next week is to generalize the idea what we have seen through F test, right? The idea is we actually have extend the idea of equal variance idea. Okay, we have compared boys and girls, whether their mean the same or not, right? There's only 2 groups. ANOVA, which we will learn next week, is instead of boys and girls, we have boys and girls, LGBT, helicopter, all the thing together, the same or not. Okay, more than 2 gender. You have multiple gender. Can you do the same? Yes. You will do ANOVA. That's it. So it's a compare different groups, whether the same mean or not. assuming they're equivariance. Okay, that's something we talk about. That is analyze of variance ANOVA. We'll talk about next week. But I will ask the TA to release the other assignment. Again, should be fine. Okay. The last assignment is very simple, so don't worry. Only this one is the most substantial one, the next one. So this one is very substantial one. Okay. So I will see you next week. Good luck for your other projects and exams. Bye-bye.